Hello kids, welcome to another session of Amazing World of Science and one-stop place for NCERT line to line for classes 9, 10, 11 and 12. Mainly we are focusing on science and chemistry for class 11 and class 12. So today we are going to continue with class 10 science. We were doing chapter 3 metals and non-metals, and we are going to continue today with the topic occurrence of metals. So already we learned in our last session about the properties of ionic compounds, and today's topic is very important. That is when you go to higher classes also there is high importance for this particular topic. So first of all we will see how you can or in what way metals can occur in nature. As you all know, Earth's crust, so many metals are there in the Earth's crust. Also seawater contains suitable salts like sodium chloride, magnesium chloride and all that. And normally the elements and compounds which you can see on the crust of the Earth, they are known as minerals. And you can see that in particular places minerals has high percentage of a particular metal, and from that mineral you can very profitably extract the metal. So such metals which are extracted from minerals are called ores. So remember what is meant by ores. Okay, now how do you extract metals? So all of you should be wondering that you can see so many minerals on the Earth's crust, and how do you separate metals from these minerals? So there are different processes by which this can be done, and we have already learned about the reactivity series of metals. And what is the importance of learning the reactivity series? You can easily know how a metal can be extracted or removed from the ore. And you can see some metals directly or they occur in free state in the Earth's crust, and some other metals are found in form of their compounds. And as you all know, the metals which come at the bottom of the reactivity series are least reactive, and these metals are found free in nature. See, you can see this chart. These metals, gold, silver, these are all coming at the bottom of the reactivity series, and they are found in nature in free state. Okay. Now, the most reactive elements are placed at the top of the reactivity series like potassium, sodium, calcium, magnesium, aluminum. These metals are highly reactive and they can be separated only by the process of electrolysis, and which are moderately reactive like zinc, iron, lead, copper. These are all extracted by the reduction of their ores with carbon. Okay, now see, for example, gold, silver, platinum, copper, they are all found in free state, and copper and silver are also found in these two, copper and silver, they are found in a combined state with their sulfur or oxide ores. And as I already said, metals at the top of the activity series, they are very reactive, and you can never see them as a free element because they always have got a tendency to react with other elements and be in a combined state rather than be in a free state. So, and the middle of the reactivity series, they are not very reactive. So they are found in the Earth's crust mainly as oxides, sulfides or carbonates. And because why many of the ores are found as oxides? Because oxygen is very reactive element, and plenty of oxygen is there in the Earth's crust. So mostly they combine with oxygen and form compounds. So this is how the reactivity series, on the basis of the reactivity series, you can group metals into mainly three categories. That is, one, low reactivity, medium reactivity and high reactivity. And based upon this, using different techniques, we can separate the corresponding metal from each category, and for that many steps are involved in the extraction of pure metals. You can see a short summary of how this is done here. So mainly ore concentration is done. We said three categories are there: high reactivity, medium reactivity and low reactivity. For high reactivity, mainly electrolysis is done to get pure metal, and here medium reactivity, mainly carbonate and sulfide ores are seen. So if the ore is carbonate, you use the process calcination. If it is a sulfide ore, we use method of roasting. You have learned already about calcination and roasting. That is the substance is burned in the presence of air and or in the absence of air. So depending upon that, we get the oxide of the metal when this process is done, and finally from the oxide we can do reduction with carbon, and finally purification of the metal. Here metals of low reactivity, sulfide ores. If it is sulfide ore, we do roasting, we get metal, and finally we do refining. Okay, now once that is done, the ores which we get from they are usually having so many amount of impurities like soil, sand. These impurities are known as gangue. So impurities should be removed from the ore before you do the extraction of the metal. So what process is used to remove gangue from ore? That is based on the differences. How is it done? That is chemical properties and physical properties. Based upon that, the difference in them, we do the separation, and accordingly suitable method of separation or suitable technique is employed. Now when you talk about the extraction of metals in the low activity series, so these metals, they are mostly very unreactive. So the oxides of these metals can be reduced to metals, only you just need to heat it. See, for example, mercury, cinnabar HGS, that is an ore of mercury. So when you heat that in air, firstly HGS is converted into HgO, see, just by heating. From HgO, simply by heating you get mercury. So this is very easy just by heating alone. And similarly, normally copper is found as Cu2S, okay, and just by heating Cu2S you get the oxide, and from that oxide again heating both Cu2O with Cu2S, these two combine again, just by heating it again we get copper metal. And how do you extract metals from the middle of the activity series? So in the middle of, you normally see metals like iron, zinc, lead, copper, etc. Normally you can see them as their sulfides or carbonites, and very easily you can obtain from the oxide, or because rather than extracting from sulfide and carbonate, it is very easy to extract these metals from their oxide ores just by heating them. And before doing the reduction, suppose if the ore is sulfide or carbonate, you have to first of all convert it into metal oxides. Why? As I told you before, it's very easy to extract the metal from the oxide ore. So first of all we convert it into oxides by heating strongly in the presence of excess air. We call it roasting. So what is roasting? Heating the ore in the presence of air. Then if it is carbonate ore, in limited air we heat it, and that process is known as calcination. Remember the difference between the sulfide ore and carbonate ore, then roasting and calcination. And reaction which takes place is zinc sulfide with the oxygen, you get zinc oxide, and calcination, zinc carbonate. If it is carbonate ore, just by heating it you get zinc oxide and carbon dioxide, and then correspondingly the metal oxides are reduced to the metals by using reducing agents like carbon. So suppose when zinc oxide is heated with carbon, you get metallic zinc. Now you are now very thorough with the process of oxidation and reduction. Already we learned that in the first chapter also, and we get metals from their compounds by reduction process. And also besides using carbon or coke to reduce metal oxides to metals, we can also do that by displacement reactions. For example, highly reactive metals like sodium, calcium, aluminum, they are used as reducing agents. So I hope you clearly understood the process of extraction of metals. And also here when you use strong metals like manganese and all that, they have a property to displace metals of lower reactivity from the compounds. Like instance, manganese oxide, if it is heated with aluminum powder, what happens is that aluminum combines with oxygen and manganese ore is separated. So these reactions are very highly exothermic, means lots of heat is involved. So the metals are produced in the molten state. Suppose in the reaction of iron oxide with aluminum, that is, these reactions are used to join railway track or the crack in machine parts. So remember, this is known as thermit reaction. Sometimes this comes for the exam. Like you have to remember the equation also. Fe2O3 plus aluminum gives Fe plus aluminum oxide plus heat. So in our next series, we'll learn about extracting metals to the top of the reactivity series, then refining and corrosion. So with the 3 topics, we'll be coming to a conclusion of this lesson. So as I always say, children, many of you are watching the channel without subscribing to the channel. Please do subscribe to the channel so that when I post new videos, you will be getting the notifications immediately. And I am also very happy to see all your comments for the different videos which I am posting. Your comments and suggestions are welcome. So just watch the video, learn the lessons well, and I'll be coming soon with the next part of this particular topic. And till then, thanks for watching. Bye.